In the following video we will show the effect the magnetic braking unit has on reducing the landing spike for a loaded counter movement jump. In this case we'll first show a 0% braking with a 40 kilogram load. We go into the collect and analyze window at this point. Since we're only going to be using force, we can go to calculate based on and uncheck displacement. Then zero the force plate with no mass on it. We're then going to go to Tools, Configure, Brake Controller, and set the brake control to 0 and apply. This means there's now no braking on the load. We're going to have the athlete stand in the center of the plate and click the start button. Perform the jump. We have them rack the bar. We now go in, we're going to set the system mass. So we check set point 1. Click on the straight portion of the graph, set point 2, click on another straight portion of the graph, click set. This enters the system mass. We can then move set point 2 to the other side of the jump, and this will give us our peak force, which is the spike from landing. We can save that data to an Excel file. We'll now go and do the 20% braking with the 40 kilo load. So we go into Tools, Configure Brake Controller, enter 20, click Apply. So now we've got 20% braking on. Go back to the collect and analyze window, and zero the plate with no mass on it. Then have the athlete take up the bar and step onto the plate. Once he's in position, we can click start and have him perform the exercise. Then once again go in and set the system mass, click on the set button, and then we, in this case, because the landing spike is actually lower than the newtons produced in the concentric phase, we're going to select the individual landing spike as shown here with set point 1 and set point 2. Then we can click on the Save tab in Results of Data Processing. And then go to our Excel spreadsheet and have a look at the two values we got for those exercises. The 20% brake load setting means that the brake load is applied set at 20% of maximum brake load setting. On this FT700 system, the maximum brake load setting was set at 180 kilograms. Therefore, the 20% load setting equates to a 36 kilogram brake load, which is 20% of that 180 kilogram in the eccentric braking load phase. Note how in this instance the total system mass was 113 kilograms, and with just a 36 kilogram brake load setting it removed 1,100 newtons in eccentric landing spike. It is this landing spike that prevents athletes working with heavier free weight loads. So now when using even heavier training loads, we are still able to set the braking level to safe and manageable landing loads using this technology. Otherwise, by just using heavier free weight loads, athletes would not be able to safely handle these far higher eccentric landing spikes.